Hi everyone, my name is Roy Wong. So I'm the trainer of the WLAN SCMP. Okay, so today we're going to start from this WLAN in the AC roaming. So the most obvious advantage of the WLAN network is that the SDA can be moved within the WLAN network without the physical media restriction. Because what we know, when we connect to the wiring network, so when all the equipment like our notebook or maybe the PC trying to connect using the LAN cable, the wire, so we have the problem when we're trying to move around. So the WLAN give a lot of the advantage to us, so we can able to move the terminal to anywhere that we want. So and also the ESS include the multiple AP, okay, to perform the roaming. Why we require the roaming? Because for some of the building, they have a very large space. So one of the AP, they might not able to cover the entire room. So in order to have the full coverage for the same area, so we require more AP to do that. So the class describe the WLAN in the AC roaming technology and some of the typical configuration. So this is where we're going to start from here. So let's look at the objective. You're going to describe some of the basic concept of the roaming and understand the difference between the layer 2 and the layer 3 roaming. Understand the difference between the fast roaming and what is the non-fast roaming. Implementation, the principle of the in the AC roaming, typical application scenario, and the last one is configure the inter-AC layer 3 roaming. So we will start from the first content overview. So here is mentioned why roaming is necessary. So as I mentioned earlier on, when we only using one AP, most of the AP they have some what we call the limitation of the coverage area. So they might not able to give the full coverage in some of the large spacing area. So in order to perform the full cover in the same space, so we need have multiple AP. Then the second one is the basic concept of the roaming. So here is the definition of roaming. So the WLAN roaming allows the SDA to move from the coverage area of the single AP to another AP with the non-stop service transmission. So that means when the SDA trying to move from one area into another area, you can see from the picture here. So the SDA trying to move from the AP1, the previous one connect to the AP1, but when they perform the roaming and go into the area number 2, so you start to connect to the AP2. So this is what we call the roaming here. This is the purpose of the roaming. So the roaming offers the following advantage. You can avoid the packet loss or the service interruption caused by the long-term authentication, because you might not want to do the authentication again when you try to move from one area into another area. You want to enjoy the non-stop the continuous services from the internet. Retain the SDA authorization information. So you no need to do any authentication anymore. And same to the IP address. And here is some of the example for the network architecture. So right here, they're using 2 different AC and 3 AP here. So the hash AP is referred to the home AC. Okay, hash AP is the home AP. Okay, the F on the front one is referred to the foreign. Okay, foreign AC and also the foreign AP. So when the roaming is happening within the same AC, so we'll call as an intra-AC roaming. So as you can see from here, the picture, the AP1 and AP2 is managed by the AC number 1. So when two different AP managed by the same AC, so we're going to call this as a intra-AC roaming. Then you can see on the next one, when the SDA try to move from the AP2 to the AP number 3. So AP2 is managed by AC1 and AP3 is managed by AC2. So in this case, we'll call this roaming is inter-AC roaming, the room between two different AC. So here is the intra-AC roaming. Roaming allows the SDA to move within the coverage area of APs, okay, the multiple AP, belonging to the same ESS, extended services with non-stop service transmission. So in order to perform the roaming, you need to make sure these both AP sharing the same ESS. So this is the inter-AC roaming. So you can clearly see from the picture here, they're showing two AC. One AC will become the master controller. So when the AP managed by two different AC, and now the PC trying to move the connection from the AP1 to the AP number 2. So this kind of roaming we'll call it as a inter-AC roaming. So in order to perform this one, you have to choose the AC. One of the AC become master controller is very important. So in order to create this one, you need to build a mobile group, okay, mobility group, to tell the AC who is the master controller right now. So after they've formed the connection here, they will automatically form another tunnel they call as an inter-AC tunnel. So this inter-AC tunnel can build through the layer 2 or layer 3. Content number 3. Different roaming mode. So the WLAN roaming can be categorized as a follows. Layer 2 roaming. When the SDA perform the roaming is within the same subnet or maybe the same VLAN. For the layer 3 roaming is when they roam between the different subnet. So here is a fast roaming. The user does not need to perform the authentication again during the roaming. Okay, this one also apply to the normal roaming. Okay, instead the fast roaming here. Okay, fast roaming can be implemented only when the security policy is WPA2 and you using the 802.1x for the authentication. Fast roaming cannot achieve in the normal authentication mode, okay, only in 802.1x, and also the encryption type select the WPA2. Fast roaming can be implemented only when both AC and the SDA support the fast roaming. Okay, both sides they must able to support, or else you can't able to enable this feature. And the last one, fast roaming is implemented using the pairwise master key, for short we call as a PMK. So later on, you're going to explain what's a PMK. So you can see the table from here. It's a comparison between the WEP, WPA, and also the WPA2. So to show you whether the access authentication is required again. Because sometimes when we perform the roaming, alright, after you roam from the AP1 into the AP number 2, you might ask the user to do the authentication again, or else they cannot access to the network. Okay, whether the SDA support the fast roaming or not. And the last one is the roaming mode. Right now they can able to perform. So you can see from here, right, we have two WEP. So the first WEP is Open System Authentication, OSA. So basically for this kind of WEP, no need to do any authentication. So we just click on the SSID and the user can straight away go online. Then the other one is using the share key authentication. The user requires you using the authentication password to log in. So you can see from here, on the first one, right, both of these authentication, the security policy, it doesn't require any re-authentication again. Okay, the user, when they perform the roaming, they still maintain the same IP address, and also they don't need to do the re-authentication anymore. But the next one, you can see for the WEP, it's not supported fast roaming. Okay, none of them can able to run the fast roaming. Then the next one, WPA or WPA2 when using the PSK. Then the next is the WPA using the 802.1x. For these two modes, they are not allowed to running the roaming. So this is the reason why sometimes when you do some testing, okay, then you notice when one terminal roam from one area into another area, why the client required to do the authentication again? So because of the security policy that you set, if you're going to using the WPA, WPA2 with the PSK, or maybe currently using an 802.1x to doing the authentication, but the security encryption rate, we're using the WPA. So basically, this kind of security policy is not allowed to do the free authentication. This means when you perform the roaming from one area into another, you have to do the authentication again every time you roam from to another new area. And same to the WEP. Both of them cannot support the fast roaming here. So if you want to run the fast roaming, there's only one security policy that we can apply, and we call it as a WPA2, and we're using the authentication type is 802.1x. So this is the only one that can support fast roaming. So right here, you look at the comparison, right? They have two different modes. One is support, and the other is not support. So let's look at the first one. When not supported the roaming one, because they're using non-fast roaming. And the PC, right? When the PC don't support the fast roaming, mean no matter how you're trying to change the security policy, right? When the PC is not supported the fast roaming, then they still can't able to perform anything. Alright, so when the user try to roam into the new area, they still have to do the authentication again. So you need to make sure both sides, the AC and also the PC, can support the fast roaming. Yes, then they can able to achieve this, right? And no need to do the authentication after the roaming. So this is a process for the non-fast roaming when we're using the 802.1x authentication. So starting, the PC, the SDA, required to associate with the AP. This one is the first process. After AP perform the associate response, then they will start to send the EAP request identity to the AC. AC, we're going to base all the information from the PC here and do the identity, going to check. So whether this is the allowed MAC address to form the connection with me or not. Okay, if everything is belong to the whitelist, so that means the AC will going to connect with the PC here. Then it will send the radius request to the Agile controller, or maybe the radius server. So you can see the process in the box over here, they always belong to the 802.1x authentication. On the previous topic, I already showed you the configuration and also the process of the 802.1x. So this is a process for the 802.1x. So after they form the connection to form the 802.1x, okay, the port is open for the client to access to the internet. The last one, they're going to share the key. Okay, this is between the AP and the station. So the PMK, right, is happening in the 802.1x authentication here. When the AC and the SDA can support the fast roaming. So first time, when the AC want to associate with the PC, they have to go through this process. After they go through this entire process to exchange the EAP process, the radius request, authorize everything inside the authentication here. And then they're going to create one table. This table, right, will be used for the later on when the AC receives the PMK from the STA, okay, from the PC. So when the PC trying to roam from an AP into another new AP, the PC no need to send the EAP request identity again. It's not necessary because this process is taking very long. So that's why this one, right, they might interrupt the PC to perform the fast roaming. So in order to perform the fast roaming, right, they're using a PMK to solve this problem. So when the PC move from AP1 into the AP number 2, so the AP is going to send the PMK to the AP number 2. When the AP number 2 receives the PMK key, they will send this information back to the AC and let the AC to check the 802.1x authentication. They have this entry of the PC or not. If yes, then the AC will connect the PC client through the AP number 2. So you can see with this technology, they can perform the fast roaming here. So this is the fast roaming process I explained just now. Only the starting, they need to associate with the PMK ID. Okay, associate response in between the PC and the AP. Then the next one, what they need to do is just keep exchange the key negotiation. So they have the following advantage. The AC save the PMKs obtained by the SDA in the previous authentication. Only the first time the PC have to create the EAP dummer and pass the identity from the 802.1x. Then later on, they don't need to go through this process anymore because all this process will be stored inside the table, inside the AC. During the roaming, the SDA send a reassociate request packet that carry the PMK ID. Okay, this is the ID, the PMK ID. So when the new AP receives this PMK, they will know this PC previously is already passed the authentication from the 802.1x. So they don't need to do the authentication anymore. The AC received the reassociate request packet and search the PMK caching table for the PMK. So if previously the PC, the SDA is already do the association with the AC, so they don't need to redo it anymore. So they automatically form the connection to the PC client.